So guys, this is one more question which appeared in GATE 2018 morning session. Okay, so mechanical engineering obviously. So this question is totally based on steady flow energy equation. So what the question says is that the steady state flow conditions through a nozzle are given like this. Okay, so at the inlet the flow velocity is almost zero. The incoming enthalpy is 2500 kilojoule per kg. The outgoing velocity is unknown and the outgoing enthalpy is 2350 kilojoule per kg. The mass flow rate through the nozzle is 0.1 kg per second, and per unit time the heat loss from the nozzle boundary is 5 kilowatt. So they are asking us what is the value of C2. So it is very important, easy. We know that in such conditions we simply have to apply the energy conservation principle, and for steady state flow through open systems, the energy conservation principle is known as steady SFEE, right? SFEE, steady state flow energy equation, which is nothing but incoming energy is equal to outgoing energy. So we have enthalpy H1, incoming enthalpy, flow velocity, kinetic energy per unit mass coming inside, potential energy per unit mass coming inside. I'm sorry, in this there is a mistake. There should be a G also here, right? We are talking of energies per unit mass, not per unit weight. Now it is equal to outgoing enthalpy, outgoing kinetic energy, outgoing potential energy, and outgoing heat loss. But do remember this, that whenever we write this equation, it is in terms of energy per unit mass, not in terms of energy per unit time. So in order to find out, we have to find out what is the Q dot, that is heat loss per unit mass of fluid coming inside or fluid going outside. Now it is given that heat loss per unit time is Q dot, which is 5 kilowatt. And we know that the mass flow rate is 0.1 kg per second. So simply divide the heat flow rate, heat loss rate by mass flow rate, you will get heat loss per unit mass of flowing fluid. So that is 50 kilojoule per kg. Now we know what is the value of H1, that is 2500 kilojoule per kg. We know what is H2, 2350 kilojoule per kg. Please note, it is kilojoule. So 10 raised to power 3 factor is there, right? And we can take this nozzle to be horizontal. So Y1 and Y2, they will cancel out, they will become 0. It is also given that C1 is also equal to 0, almost equal to 0. So from this you will have C2, which is twice of H1 minus H2 minus small q dot under root. Just substitute the values. Please note that all these terms are in kilo. So take a factor of 1000 also, and your answer will come out in meter per second. So this is the solution to this very simple question, very easy to answer. So for any discussion or any doubt on this, you can contact us, and the number is there on the right hand side, 080 617 22 666. Thank you.